Mathematics is full of functions, so we're going to need to know how to define functions in Python. That's the subject of this video. To define a function in Python, you have to do three things. First of all, you type the word def, short for define, then the name of the function, and then in brackets, some variables to represent the inputs to the function, and then a colon. Next, you type the body of the function, which means the code used to define the output of the function. That code has to be indented by 4 spaces, which means you have to type 4 spaces before each line of code which are part of the function definition. Finally, you use the word return followed by what you want the function to output. Let's do a really simple example. We're going to define a function which computes the square of its input. We have to type def, then the name of the function, which is going to be square, then a variable in brackets to represent the input of the function. It can be any Python variable name. Let's just use x. Finally, we need a colon. Now we're going to type the code used to compute the output of this function. When I press enter here, you can see that a Jupyter Notebook automatically inserts the 4 spaces that I need to show Python which bit of code is part of the definition of this function. This is a really simple function, so we actually only need one line to compute the output. So we specify the output with the word return, and what we want it to be is the square of x, which in Python is computed by x, and then 2 asterisks, and then 2. Once I execute this code cell, I now have my own function f, which I can use to square numbers. So let's move to the next cell and actually make a call to that function. Evaluating a function in Python is called calling it. So if I type square 4 and then run this cell, what it will give me is the output 16, 4 squared. What happens when you type something like square and then 4 in brackets is that Python will go back to the definition of the function, substitute the number 4 in place of the input variable x, and when it sees a return, it will substitute square brackets 4 with whatever came after that return statement. So in this case, square 4 gets replaced by the number 16. So you could even use this in a calculation if you like. If we wanted to work out 4 squared plus 1, we could type square 4 plus 1. When Python evaluates this line, it'll first look at the function called square brackets 4, work out that that's 16, add 1, and now the output will be 17. Let's do another simple example. We've been working with a quadratic f of x is 2x squared plus 5x plus 2. In the next cell, I've defined some variables to represent the coefficients of that function and other variables for the roots of that quadratic. Now we're going to define a function which computes values of that quadratic function. We will use the word f to represent our quadratic. So to define the function on line 1 there, I have to type def to tell Python I'm about to start defining a function. Then the name of the function, which will be f. Then in brackets, a variable used to represent the input of the function. I'll use y. After the list of variables, we have to use a colon. And then on the next line, we specify the output of the function using the keyword return, followed by what we'd like the output to be. In this case, 2y squared plus 5y plus 2. When I execute this code cell, I now have a function called f, and I'm going to test it by evaluating f of the 2 roots which I defined 2 cells ago. If I've done both of those things correctly, I ought to get the answer 0. Let's try it. 0 and 0. So things seem to be working okay. The 2 functions we met so far only had 1 input, but Python functions can have as many inputs as you like. Let's define a function with more than 1 input to see how that works. The simplest 2-variable function I can think of just adds its 2 arguments together. So let's write a function which adds together 2 numbers. First we type the keyword def, then the name of our function, which is just going to be add, and then in brackets 2 variables to represent the inputs of the function. Let's call them a and b. Then we need a colon. On the next line, which has to be indented by 4 spaces, we're just going to use the word return to say what the output of the function should be. So let's type return, and then what we want the output to be, which is just a plus b. Again, as soon as I've executed that code cell with the function definition in it, I can call that function just in the usual way, so add 3, 4. When I execute this, I'll get the answer 7 as expected. Now we're going to learn how to display things on the screen in Python. You do this with a special built-in function called print. If you type print and then something in brackets, Python will print that something on the screen. For example, if you want to print some text, you can type print and then in brackets the text in double quote marks or single quote marks, and Python will display that on the screen. So when I run this code cell with print quotes hello in it, I'll get the word hello. Running the next cell, which has print and then a number in brackets, it'll display that number on the screen. And you can use this print command or print function wherever you like, including inside a function. So let's go back to our definition of the function add and extend it a bit so it tells you what it's going to do. So inside our definition of the function add, so that's called the body of the function, we're going to add some print commands. The first line will say I am going to add, and then a, and then the word and then b. So when we executed this, we've now changed the definition of the function add so that it tells you what it's going to do before it does it. Let's re-execute this cell where we add 3 and 4, and you can see what we get now is that it prints out all of those things. This can be really useful when you have more complicated functions and you're not sure whether they're computing things correctly. For example, if your function involved lots of calculations to eventually arrive at some answer at the end, you might want to print out the result of these intermediate calculations to check that you get what you expected. Now at the moment this doesn't really look very nice because all the text is on separate lines. We can fix this by changing the way we use the print statement. In fact, print is a special Python function. It can take as many arguments as you like, as long as you separate them by commas. So if we want to have all of those things appearing on one line, what we can do is just give the print function multiple inputs separated by commas. So we'll change this to print I am going to add, comma a, comma and, comma b. And if we re-execute that definition and then call add 3, 4 again, what we'll get now is a nicely formatted I'm going to add 3 and 4 followed by the answer, which was 7. A common mistake which beginners in Python make is to confuse a returned value from a function, so the output of the function, with something which is displayed on the screen. Those are different concepts. When a function returns a value, you can use that value in a computation. We've already seen an example of this where we computed the square of 4 and added 1 to it. You can't do anything with a value which is just printed on the screen. All that happens is it gets displayed and then it can't be reused in any way. Let's see an example of that. In the next cell, I have 2 functions. The first function, f, simply takes an input x and then prints the value of x plus 1 to the screen. There's no return command, and that's absolutely fine. Python functions do not have to return anything if you don't want them to. So all f does is print out the value of its input plus 1 on the screen. On the other hand, the function g takes its input, x, and adds 1 to that input. Then it returns that input. So g of x actually computes an output and gives you back that output, which you can then reuse in a calculation if you like. Let's run this code cell to define those 2 functions. Now we're going to run f. When I run f, what happens here is it prints out the value of its input plus 1. So I called f of 1. So we work out x plus 1 and then print it to the screen. You get 2. When I run G, again this time it looks slightly different because you can see I've got the word out. That's telling me that my function G actually produced some output. It didn't print anything to the screen itself, but the Jupyter Notebook saw that the output was 2, and so it displayed it with the word out next to it to tell you that your function actually outputted something. Let's now see what happens when I do G of 1 plus 1. Remember, the function G actually returns a value. So what will happen here when I execute the code cell containing G of 1 plus 1 is that Python will look at the definition of G, figure out that G of 1 is 2, replace G of 1 with 2 and add it to 1, so the output will be 3. Now let's see what happens when I do this same thing, only with F in place of G. I get an error. Forget about what the error says at the moment. The problem here is that F didn't actually return an output at all. So if you look back at the definition of F at the top of the screen there is no return statement. All F does is print out the value of its input plus 1. So when you try to do f of 1 plus 1, that's an error. F of 1 isn't anything at all. In fact, it's what Python calls a none type. But all you need to know is that that is nothing. And so when you try and add nothing and 1, you get an error in Python. Python only knows, Python can add numbers, but it can't add nothing to 1.